884,000 tokens. That's what it costs to give an AI agent a toolbox. Not to do the work, just to read the menu. Every time your agent gets a task, it opens a context window and dumps every tool it has access to inside it, all 2,209 of them. Cloud infrastructure tools, finance tools, databases, security scanners, e-commerce integrations, the whole catalog, every single time, whether the task needs one of them or all of them. The agent reads the entire library to pick one book. Then, Alibaba published a paper that fixed it, and the number is almost too clean to believe. By the end of this video, you'll know what the actual problem is and why the obvious fix made it worse, exactly how SkillWeaver solves it in 3 steps, the weird finding buried in the benchmark that should change how you think about bigger models, and what it doesn't do yet, because there's always a catch. Start with why the number is real. Most 99% claims in AI are marketing. This one comes from a benchmark. Researchers at Alibaba built something called Comp Skill Bench, 300 multi-step queries, tested against a library of 2,209 real-world skills pulled from the public MCP ecosystem. Finance tools, cloud infrastructure, databases, code execution, 24 categories total. Real tools, not synthetic ones. The kind of messy, sprawling catalog an enterprise agent actually has to navigate. The baseline they compared against was the honest version of how most agents work today. Take the task, dump every tool description into the prompt, let the model figure it out. That approach consumed an estimated 884,000 tokens per query. Not 884,000 for a big, complex job, 884,000 per query, and got the right tool category 21.1% of the time. SkillWeaver consumed 1,160 tokens per query. Not a 50% reduction, not 80%, 99.9%. Here's the problem it's actually solving, because the headline number hides it. The problem isn't that AI agents are slow or dumb. The problem is that they treat every task like a one-shot decision. You ask an agent to download the dataset, transform it, and create visual reports. 3 distinct jobs, each requiring a different tool, maybe 4 or 5 tools total. The agent has 2,209 of them loaded into its context, and it makes a single pass, reads everything, picks something, commits. This is called one-shot tool routing, and it fails on compositional tasks, meaning any real-world task that requires more than one tool in sequence. Alibaba's paper formalizes this failure as the compositional skill routing problem. The name is academic. The cost is not. When your agent gets it wrong, it doesn't throw an error. It just produces the wrong output confidently at full price. SkillWeaver fixes it in 3 stages: decompose, retrieve, compose. Stage 1, decompose. Instead of handing the agent the full task and asking it to figure out the tools, you break the task into atomic subtasks first. Download the dataset is one subtask. Transform it is another. Create visual reports is a third. Each subtask is small enough that the tool it needs is obvious. Stage 2, retrieve. For each subtask, a lightweight embedding model runs a semantic search against the tool library. Not all 2,209 tools, just a short list of the top candidates for that specific step. The tool descriptions that matter get surfaced. The 2,100 that don't never touch the context window. Stage 3, compose. A planner evaluates the retrieved candidates and checks whether the output of tool A naturally flows into the input of tool B. Then it assembles a directed acyclic graph, a DAG, that maps the dependencies so independent steps can run in parallel and sequential ones run in order. The result is an execution plan, not just a list of tools. That is why the token count drops from 884,000 to 1,160. You're not feeding the model a library. You're feeding it exactly what it needs for each step. Now, the part that sounds like the fix, but isn't. Inside the decompose stage, there's a problem the researchers had to solve separately. Language models, when asked to decompose a task, tend to generate generic descriptions, not specific enough to retrieve the right tool. Process the data is a valid subtask in plain English. It matches nothing in a tool library indexed by specific names like CSV-parser or data-pipeline-executor. The vocabulary doesn't align. So the retrieval step fails not because the tool doesn't exist, but because the subtask description was too vague to find it. The fix is a feedback loop called skill-aware decomposition, or SAD. The agent drafts an initial decomposition. SAD retrieves tool candidates based on that draft. Then the agent revises the decomposition using the retrieved tools as hints, aligning its vocabulary to what actually exists in the library. One loop. The tool hints anchor the description to reality. That feedback loop took decomposition accuracy from 51% to 67.7%. On hard tasks requiring 4 to 5 tools in sequence, it improved accuracy by 50%. Here's the finding that should stop you for a second. The researchers tested SkillWeaver with a 7 billion parameter model, Qwen 2.5-7b-instruct. Lightweight, cheap. Then they ran the baseline, the naive dump everything in the prompt approach, with Qwen Max, a much larger, much more expensive proprietary model. The bigger model, unguided, got the right tool category 21.1% of the time. The smaller model, with SkillWeaver, got to 67.7%. It gets weirder. When they ran the larger model without the SAD feedback loop, its accuracy actually dropped below the 7B model. The larger model over-decomposed. It broke tasks into microscopic, unnecessary substeps that didn't match any real tool. More parameters made the problem worse. The paper's conclusion is direct. Task decomposition granularity, not model size, is the primary bottleneck in tool routing. Aligning the agent to the specific vocabulary of your tool library is more impactful than paying for a bigger model. That's not a research footnote. That's the whole premise of agent infrastructure inverted. Now the part Alibaba would rather you skim past. SkillWeaver doesn't have error recovery. If step 2 in a 5-step tool chain fails, an API times out, a tool returns an unexpected format, anything, the entire chain breaks. There's no retry logic, no fallback, no graceful degradation. The researchers flag this themselves in the paper. Any team shipping SkillWeaver into production needs to build their own error handling around it. The source code also hasn't been released. What exists is the research paper and a set of prompt templates. You can implement the architecture yourself using LangChain or Llama Index. You can build the face index, wire up the retrieval, implement SAD manually. The recipe is documented. The kitchen is not. The benchmark was also Alibaba's own. Comp Skill Bench was built by the same team that built SkillWeaver. The 300 query test set, the 2,209 tools, the evaluation criteria, all internal. That doesn't mean the numbers are wrong. It means they haven't been independently verified yet. And 76.7% chain completion rate in the pilot execution study, which sounds strong, was run against mock executors, not live APIs, not production systems, mock environments that don't fail the way real infrastructure does. The token numbers are real. The production story is still being written. Zoom out, and the finding underneath this paper matters more than SkillWeaver itself. The assumption baked into every AI agent platform right now is that tool routing is a model problem. Give it a better model, it picks better tools. That's why everyone's racing to wire GPT 5.5 or Opus into their agent orchestration layer. That's the bet the whole market is making. Skillweaver is evidence the assumption is wrong. Routing is an architecture problem. A 7 billion parameter model with the right decompose, retrieve, compose structure beats a frontier model guessing from an 884,000 token prompt. The bottleneck was never the model. It was how the model was being asked to work. That reframe is the thing worth keeping, regardless of whether Skillweaver itself becomes the standard. The agents that win at scale won't be the ones with the biggest brains. They'll be the ones with the best librarians.